Welcome, listeners, to Astro Narratives. Tonight, we embark on a journey not just across space, but across time. From the flicker of distant stars to the pulse of engines yet to be built. From the dusty trails of Mars to the shimmering clouds of exoplanets light years away. This is the story of where we're headed next, into the unknown. This is the future of space exploration. It begins with a silence, deep and eternal, hanging like a question mark over the heads of dreamers. For centuries we gazed upward, wondering what lay beyond the sky's curtain. But now we stand at the brink of turning wonder into reality. The spacecrafts are real. The blueprints are drawn. The countdown has begun. Let us first drift toward the moon, our ancient companion, silent and scarred. We have visited her before, but only briefly. Now, in this new chapter, we return not just to touch her surface, but to stay. Artemis, the name of a goddess, and the name of our return. NASA's Artemis missions will establish a sustainable lunar presence, a base camp from which humanity can leap even farther. Picture this: metallic habitats rising like silver domes in the gray dust, astronauts walking beneath the shadows of Earth's reflection, and science unlocking secrets preserved in lunar ice. And why the moon? Because it is both a destination and a doorway. A place to practice survival beyond Earth, and a launchpad for even grander adventures. Mars is next, not as a distant red dot, but as a second home. Imagine the first human footsteps pressing into the rust-colored sands of Mars. A Martian sunrise, pale and cold, stretching across the horizon of Olympus Mons. Not a dream. Not anymore. SpaceX envisions this future boldly. Starships, those towering vessels gleaming with stainless steel, may one day ferry settlers by the dozens. The journey months long across the void, landing on a planet that never knew life. Until we brought it. But to live on Mars is to defy nature itself. Radiation, dust storms, temperatures that would freeze breath to crystals. Our future pioneers will build domes, transparent, pressurized, filled with oxygen from electrolysis, water from subsurface ice, crops nourished by recycled waste. They will speak not of Earth days, but of Sol's. Their clocks will tick to Martian rhythms. Their children may be born under alien skies. Yet Mars is not the final frontier. It is merely the beginning. For beyond the red planet lies the Kuiper Belt, a frozen empire of ancient comets and dwarf planets. Robotic explorers like New Horizons have already whispered their stories back to us. But one day, we may send swarms of AI-driven probes, self-replicating perhaps, each leaping from one icy world to the next, building a network of sentinels watching the outer edges of our solar dominion. And while we stretch outward, our technologies evolve inward. Propulsion systems are no longer bound to chemical rockets alone. Ion drives, plasma thrusters, and nuclear thermal engines pulse on drawing boards and test beds. But the most daring dreams ride the light itself. Solar sails, catching the pressure of photons like winds across an ocean of vacuum. Concepts like Breakthrough Starshot imagine gram-scale spacecrafts, launched at a fifth the speed of light by Earth-based lasers, racing toward Proxima Centauri and its exoplanet, Proxima b. Proxima b. an Earth-like world in the habitable zone. It's a name spoken with hope. Perhaps there, the sky is blue. Perhaps there, life pulses beneath clouds of methane or beneath oceans we cannot see. We might not reach it in our lifetimes, but perhaps our descendants will, guided by the data we collect and the dreams we pass down. Back home, telescopes grow wiser. The James Webb Space Telescope, our golden eye in the dark, is already revealing the secrets of the early universe. But imagine what comes next. Gigantic observatories on the far side of the moon, shielded from Earth's radio noise, staring deep into cosmic history. Quantum sensors, gravitational wave arrays, and dark matter detectors mapping the invisible. Our understanding of the cosmos will stretch not just spatially, but fundamentally. With this knowledge, questions grow louder. Should we terraform? Should we transform alien worlds into Earth-like havens, or preserve them as they are? Should we send humans at all, or let intelligent machines venture first? The ethics of space colonization weigh heavy. We must ask, are we explorers or conquerors? Meanwhile, space will cease to be the realm of governments alone. Private companies, eager and agile, are writing new chapters. Blue Origin dreams of space habitats, rotating cylinders with Earth-like gravity. Imagine 1 billion souls living in orbit, farming in sunlight that never sets, watching the cradle of Earth from afar. And new nations will rise, not of borders, but of access. Those who build the launch pads and claim orbits may dictate the rules of the final frontier. Space law, space diplomacy, space conflict. These two are futures we must prepare for. Back on Earth, everyday life is already changing. Satellites map crops, monitor forests, connect the disconnected. Soon, internet from orbit may be a human right. Kids born today may think nothing of seeing Earth from space on a school field trip or logging into a VR moonwalk. Our species will grow up with one foot on Earth and the other in the stars. Still, the greatest challenge may lie within. To survive among the stars, we must evolve not just biologically, but socially. We must learn patience for multi-year missions, empathy in tight quarters, resilience in alien isolation. We must conquer our divisions, on Earth first, before we can represent humanity elsewhere. In the distant future, if we survive, if we thrive, we may not just visit stars, we may build new ones. Dyson Spheres collecting starlight, artificial planets spinning with purpose, black hole power plants bending time itself. These are not fantasy. They are projections, seated in the physics we already know. And yet, in all these futures, one truth persists. Space is not a place. It is a direction, an attitude, a promise that we will not be bound by fear or gravity, or the silence between stars. We go not because it is easy. We go because the stars are watching. And perhaps, just perhaps, someone is watching us. The future of space exploration is not written. It is being carved every day by engineers soldering circuits, astronomers decoding spectra, children staring into telescopes. It is written by you, by your curiosity, your imagination, your belief that there is always more. There is something almost poetic about how space exploration mirrors the human condition. We look outward, beyond the atmosphere, because we are driven by something internal, an ache to understand, to connect, to become more than what we are. Space is vast, yes, but it is also a mirror. And as we peer deeper into it, we are really searching for a clearer reflection of ourselves. The next few decades will redefine what it means to be human. One of the most transformative tools in our arsenal is artificial intelligence. On Earth, AI is already augmenting our thinking, translating languages, analyzing data. In space, it becomes essential. Machines that think faster than we do will guide probes through asteroid fields, diagnose malfunctions in deep space habitats, make split-second decisions when Earth is too far to help. Picture an AI rover on Europa, navigating icy crevasses, drilling into the subsurface ocean, analyzing samples for microbial life. No human commands needed. It learns the terrain, it adapts, it thinks, and perhaps in its silent memory, banks it captures the first signs of life beyond Earth. Not a thunderous discovery, but a subtle pattern in chemistry, a whisper in the data. That whisper could change everything. Yet as AI grows more capable, the lines blur. Will AI be our servant or our partner in exploration? Could it one day become the first citizen of another world? We may find ourselves designing ethical systems not just for humans, but for intelligent machines that accompany us into the cosmos. The age of robotic pioneers is not science fiction. It is the first chapter of interstellar history. Then there's the question of biology. Our bodies evolved for Earth, shaped by gravity, sunlight, and atmospheric pressure. But what happens when we remove these constraints? Long-term exposure to microgravity leads to bone loss, muscle atrophy, and even changes in vision. Radiation from cosmic rays threatens DNA. Mars offers only 38% of Earth's gravity. The Moon, a mere 16.5%. So we must adapt. Or adapt our biology. Genetic engineering, already progressing on Earth, could become critical. What if we could design astronauts resistant to radiation, or tweak genes to prevent muscle loss in low gravity? Controversial? Certainly. But survival may demand it. Then again, perhaps technology will spare us the need. Artificial gravity, achieved through rotating habitats, is a growing focus. Picture giant rings, O'Neill cylinders, spinning through space, generating Earth-like conditions. These structures, once imagined in science fiction, are now being engineered on paper. Lush gardens, cities in the sky, sunlight streaming through curved windows. Entire ecosystems orbiting Earth, Mars, or even distant stars. Terraforming also enters this discussion, especially with Mars. Can we make an alien world more like home? Ideas abound. Releasing greenhouse gases to warm the atmosphere, constructing giant mirrors to focus sunlight, even deploying microbial life to alter the Martian soil. These plans span centuries, not decades. But what is time to a species with interplanetary dreams? Some scientists argue that terraforming is hubris, a form of cosmic colonialism. Shouldn't we preserve other planets as they are, learn from them, not change them? It's a philosophical crossroads. Do we see ourselves as caretakers of space or as architects of new worlds? While those debates unfold, asteroid mining may become one of the most practical developments in the near future. Floating between Mars and Jupiter lie trillions, yes, trillions, of dollars worth of resources. Platinum, gold, rare earth elements, water ice. A single asteroid the size of a mountain could contain more metal than we've mined in all of human history. Companies like Planetary Resources and Deep Space Industries once led this charge, and although they faced setbacks, the idea persists. Autonomous mining drones, zero-gravity refineries, space-based manufacturing. Not only would this revolutionize industry, but it could shift our economic foundation, resources no longer bound to Earth. And it doesn't stop there. Consider the implications for energy. Solar power in space is more efficient. No atmosphere to block the sun, no nighttime. Massive solar arrays in orbit could beam clean energy back to Earth using microwaves. Imagine solving our planetary energy crisis using infrastructure built in space. It's not fantasy. Japan and China are already testing prototypes. Of course, with every breakthrough, risk shadows hope. The militarization of space is no longer hypothetical. Nations are developing anti-satellite weapons. The US Space Force exists for a reason. In the future, control of orbital lanes could equate to global dominance. We must decide now whether space becomes a battlefield or a sanctuary. That's why diplomacy matters. Treaties like the Outer Space Treaty of 1967 laid the groundwork, declaring space the province of all humankind. But those treaties were signed in an era when only 2 nations had access to space. Now dozens do, and more will follow. The rules must evolve, or chaos will. One potential model is the Antarctic Treaty, which maintains peace and scientific cooperation on that icy continent. Could Mars have a similar charter? Could we establish a Martian Council where decisions are made globally, not nationally? These are not just questions of law. They are questions of vision. What kind of spacefaring civilization do we want to be? Meanwhile, Earth will remain our cradle for a long time. Most humans will not leave it. But space will increasingly shape our identity. Children will grow up watching rocket launches the way previous generations watched planes take off. Students will study not just geography and biology, but orbital mechanics and planetary science. Artists will paint Martian sunsets. Writers will compose poems about Europa's ocean. Space will infiltrate our culture. Religions too will evolve. Pilgrimages may occur on the moon. Chapels may rise aboard orbital habitats. The question of our place in the cosmos will no longer be metaphorical. It will be literal. Are we alone? Do we matter in a universe so vast? These are spiritual questions as much as scientific ones. And what of the search for life? That thread runs through every telescope, every probe. SETI continues to listen. Radio signals, laser pulses, technosignatures. We have yet to hear anything. But absence is not silence. It may be distance. It may be timing. It may be that they are watching us, waiting for us to evolve. Or it may be that we are the first, the only intelligent species born in a quiet corner of a quiet galaxy. If so, then our responsibility is immense. We must carry consciousness to the stars like a flame carried through darkness. Let's jump further ahead, 1,000 years. Perhaps we've colonized Mars. Perhaps Europa has underwater cities. Perhaps asteroid habitats orbit in swarms like metallic bees. Humanity will look nothing like it does today. Some of us may be digital minds uploaded into artificial bodies. Others may be hybrids, part machine, part organic. Languages will evolve. Art will change. New philosophies will emerge, born from life in low gravity, from isolation, from contact with new forms of life, or the absence of it. What does identity mean on Titan? What does society mean in orbit around a rogue planet? And still, we will look further. Interstellar travel, once the dream of dreamers, may become possible. Wormholes, if they exist, could fold space. Alcubierre drives, based on warping space-time itself, may become more than equations. We may learn to skip across the galaxy not by speed, but by bending the road itself. But if we go that far, we must take more than technology. We must take our stories, our music, our love, the very things that make us human. Because space is not just about survival, it's about meaning. And meaning does not come from the stars. It comes from us. So now, as this story nears its pause, not its end, let us reflect. We are a fragile species on a pale blue dot, orbiting an ordinary star in a spiral arm of a galaxy among trillions. And yet, we dare. We build. We launch fire into the heavens. We name rovers with words like curiosity, perseverance, and spirit. We are children of Earth, reaching for the sky. The future of space exploration is not about rockets or robots or radiation shielding. It is about courage. It is about imagination. It is about looking into a dark universe and choosing to light it up with dreams. So tonight, as you lie beneath your own sky, remember, the future is already unfolding above you, and one day you may be part of it, not as a spectator, but as a story written in the stars. Perhaps one day, on a distant world, a traveler will stand beneath a sky with no constellations they recognize, and they will whisper thanks to the generation that believed, that built, that began the journey. That generation is us.